Hi everyone, welcome back to System Verilog coding series. So in today's session we are going to see about copying techniques within System Verilog. So we are going to write a code related to shallow copy and deep copy. Shallow copy and deep copy is one of the important concept in System Verilog, and you can also expect many questions related to the codes in both shallow copy and deep copy. So you need to know what is shallow copy and what is deep copy, what is the difference between shallow copy and deep copy, how we are writing a code for shallow copy and how we are writing a code for deep copy, what are the techniques that we are using in shallow copy, what are the techniques that we are enhancing that we are using in deep copy, which are not present in shallow copy. So these are the all the topics in that we are going to talk about in this video. And before going into today's video, if you are new to this channel, consider subscribing my channel and hit on the notification bell also follow me on LinkedIn and join my Telegram channel for the latest updates related to VLSA jobs and internship opportunities that I encounter in my LinkedIn profile. So now coming to copying techniques. So basically what is copying? So copying means whatever that are present in one handle, we will be whatever variables that are present in one handle, we will be assigning that to the, for example, if we are having a class which consists of handles, right? Let us consider our class consists of two handles. So when you want to assign the first handle variables to second handle variables, what you will do, you will just assign this the class 2 variables to the class 1 variables, so that obviously the whatever that is present in class 1 will be entirely copied in class 2. Is it or not? So how we are going to write a basic copy technique, we'll be seeing now. So this is the class. Okay, so in my class I am writing a data, so this is my variable. So this is the class where I am using the variable data, okay, which is of 32-bit and end class. Now for this class I am creating two handles. Okay, so for this class which is transaction, I am creating two handles. So transaction is having two handles which are tr1 and tr2. So if you see here, tr1 is equal to new, so I am creating the object for tr1. So the memory is created for tr1. Okay, so this is the data that is created for tr1. So tr1 is having the memory in which the data variable is present. Clear? Now tr1 of data, so within the tr1 I am having data, so within this data I am assigning the value as 5, so the data value is 5. Now what I am doing, tr2 equal to tr1, that means whatever that is present in tr1 is assigned to tr2. So now what happens, the data is again given to tr2 also, where the value is 5 itself. Now, whenever you are displaying the values with tr1 of data, the value will be 5. And same thing is assigned to tr2 also. So, the tr2 value is also 5. Now, what happens if you see here, the actual problem occurs. So, tr2 of data equal to 10. So, you have changed the tr value as 10, tr2 value as 10. But what happens, even though you are changing it with the tr2 handle, the change will be seen in tr1 handle also. That means the data 1 is also changed to 10. Okay, even though you are changing it with this handle, tr2 handle, the tr1 value also will be changed. Why? So what is the reason for this? Why is this? Because if you see here, you have created the memory location for only tr1, and you are assigning everything that is related to from tr1 to tr2. Now what happens, both tr1 and tr2 handles will be sharing the same memory location. Okay, so here this is called as class assignment. This is not copy. Why? Is because whatever that is there in first handle, you are just simply assigning it to second handle. You are not creating any particular memory location for the second handle, so that there won't be any change mismatch during the first handle and the second handle. Okay, which is why what is happening, since both are sharing the same memory location, if you see the thing here, see, this is the data, and tr1 is, since tr1 equal to new, so the memory is allocated for tr1. But what you are doing, you are assigning whatever that is there in tr1 to tr2. So what happens, both tr1 and tr2 are having the same memory location. Now what happens, for example, if there is a room where two persons are having the accessibility, now what happens, any person, if any person make the changes in the room, the second person can easily visualize the particular changes. Why is it? Because both are having access to the same room, so the change made by any person is visualized in the room. Similarly, both handles are using the same memory location, so which is why any change that is made by using any of these handles also will be affected on data. That means if tr2 dot data is changed, then also tr1 data will also be changed. If tr1 dot data is changed, tr2 dot data is also changed. Which is why this is not apt, this is not called copying. Why? Because in copying, generally copying is the technique where we generally use this copying technique so that we can create some other handle, so that we can use that handle independently. But here there is no independency. The changes made by one handle will be seen in the second handle, so there is no independency. Even though we are creating a particular two different handles, even though we are creating two different handles also, both are having the same memory location, which is why this is not called copying. Okay, so in order to avoid this thing, like in order to avoid this mismatch of the handles, we have come to the concept called copying techniques, where the first one is shallow copy and the second one is deep copy. Let us now see how this shallow copy works. Okay, I'll be giving you an example, and if you see the example based on the variables and based on the classes that we have taken, I have just mentioned the entire code with different colors, so that you can easily understand which one belongs to which variable, belongs to which class, and which variable belongs to which class, right? So let us see. Now I am taking a class, so this is my first class. Okay, so my first class is error dot transaction, which consists of two variables. So what are the variables? Error data and error. So these are the two variables within my error transaction. So this is my class 1. Okay, so for this error dot data and error, I am creating the constructor function. I think you already learned about this constructor function. If you didn't see that constructor function, I link that in the description box. You can go there and check it out, like what is the need of constructor function and what is this keyword. Okay, this is very important, because basically when you enter into the real time field, like when you are developing the test bench environments also, UVM based test bench environments also, you will be seeing this constructor function and this keyword there. And this is most frequently asked among the interviews also, like what is constructor function and what is this keyword. So I link those two videos in the description box also. If you want, you can check it out there also, right? So as for now, this is the constructor function for the two variables error dot data and error. Okay, so this is my first class. So what is now, my first class consists of two variables, which are error data and error, right? So now coming to my second class. So this is my second class, which is named as transaction. Okay, so error trans is my first class and transaction is my second class. Clear? Right? So I'm having two classes. So within the transaction, I am having two variables, which are data and id. Right? So these are the two variables, and along with the two variables, I'm having another variable, which is error of TR. ERR of TR. So there is one special thing about this ERR TR. If you see this here everything I have mentioned it in blue, but this is red. Why? Because this ERR TR belongs to the first class. What is that? You already know that class is a data type, so you can use it as a user defined data type also. So what I am doing, I am making this class as a data type. So error transaction is a class, so you can use it as a data type. So with the class name I am creating a handle, okay, which is ERR TR. So these are the three variables. So one is data, one is ID, and one is ERR TR. Okay, so if you see within ERR TR, again what does it consist of? So data is a individual value variable, ID is an individual variable, but error transaction ERR TR is not an individual variable. It again consists of inbuilt ERR data and ERR OR error. So ERR transaction consists of ERR data and error. And so finally transaction consists of actually four variables inbuilt like inside. But when you are seeing outside, you are having only three variables, which is data, ID and ERR TR. Clear? So this is the thing that makes difference actually. So you should listen this carefully. Why I am particularly mentioning this? Because this is where the difference occur between the shallow copy and deep copy. Clear? Yes. So this is about my second class, which consists of data, ID and ERR TR. So these are the three variables. Now within the construct, again I am writing a constructor function where I am assigning the values to these variables. So data is 100, so I am assigning value of data as 100, ID as 1, okay, and ERR TR. So what is the ERR? How to assign the value to ERR TR? I can assign the value to ERR TR through new function, because you will be calling the function. Okay, you are just assigning values through new function. So here what I am doing, I am assigning the values through new function. So error data is nothing but all F. Okay, and then what is the error? Error value is 1. So these are the two values that I am assigning through new function to error TR. So what is it now? Data is 100, ID is 1, ERR data is all F, and finally error is 1. So this is our assigning. This is the values that I have assigned up until now. Now after assigning the values, what I am doing, I am just writing a display function in order to display all the values. See, like what transaction consists of data and ID, okay, and then error transaction consists of error data and error. So I am assigning all the values individually. Now if you see here transaction, I have just given a value as a, in order to display I have just given it as data and ID, because inbuilt it was introduced in transaction itself, so it doesn't need any path, hierarchical path, only data and ID. But if you see the second display, it is ERR TR dot ERR data. This is the hierarchical path. Why? Because ERR TR was introduced in transaction. Okay, but the root of this ERR TR is present in where? Where does it present? It is present in ERR over trans is the hierarchical path. So that is why ERR TR of ERR data, ERR TR of error. Okay, so I am assigning the values along with the hierarchical path here, so that means here from this hierarchical path you can understand that here the memory is different, because the transaction the memory is created for data, ID and ERR TR. Okay, again in ERR TR the memory is created for ERR data and error. Okay, so the memory is created for these two here, not here. Here the memory is only created for ERR TR. Okay, within this memory again you are having inbuilt, you are having this particular memory location where both ERR transaction error are present. I hope you got my point. So in shallow copy, the copying is done on handles. So basically, when you are assigning, now what happens when you are assigning when you are taking this transaction handles like TR1 and TR2, and you are assigning TR2 to TR1, then what happens? All that are present in this transaction is copied to TR2. So inbuilt what it is happening, data is copied, ID is copied, ERR, TR is copied. So the handle is copied. Okay, but the internal objects within this handle, what are those ERR, TR and error? These two are not copied. Hope you got my point. Yes, that is what shallow copy refers to. Let us see here. Okay, so here what I have done, I am taking two transactions, which in this, the first transaction I have created the memory location as, so two transactions. For the first I have created the memory, so TR1 is having the memory now. Okay, so memory location is having for TR1, and I am just calling the display method using TR1. Okay, so TR1 dot display. So where is this display? Here the display is this function. So I am calling this function with TR1 handle, not TR2 handle. So I am calling with TR one handle. Now whatever that is present in that display, everything will be displayed with TR1 handle, right? Now what I am doing, I am assigning everything in my TR1 to TR2. But if you see in the before, while we are talking about the class assignment, how we have assigned it, we have just assigned TR2 equal to TR1. So what is present, what is happening if we are just writing it like that? Whatever that is present in TR1, that is assigned to TR2. That means the same memory location is shared by TR1 and TR2. Okay, but that is not the case here. Here what we are doing, TR2 equal to new of TR1. That means what we are doing, TR2 will be having the different memory location because I am using the new, and that different memory location will be having same values that are present in TR1. Okay, so for example, if TR1 is having data, ID and ERR TR, right? So these are the three variables in TR1. The same variables will be present in TR2 also, data, ID and ERR TR. But the only difference is they are present in different memory locations. That means here data, ID and TR are error for TR1 handle. Again TR2 handle is having different memory location, where again data, ID and ERR transaction happens. Now what happens, in since they are having two memory locations here, so any changes that takes place in TR1 doesn't affect TR2. Any change that takes place in TR2 doesn't affect TR1. Clear? Now which one that is affected? Which is the one that is affected? The affected thing is this ERR TR. Why is this being affected? Because as I told you, this error transaction is the internal connection of the actual main class. Okay, which is error transaction is the class, okay, which is given a handle of err tr here. So err tr is nothing but it is the handle of error transaction, which is again a class which internally is having two different data types. Okay, so what are the data types? Error data and error. So this error data and error are the things that are affected when you are changing the TR1 and TR2 values. Why? Because as I told you, in shallow copy you are just creating the memory locations for handles. Okay, so if you see here, okay, let me give you a small example here. So what I am trying to say is, this is my TR1, this is my TR2. So my TR1 consists of data, ID, error trans. Again my TR2 consists of data, ID, ERR trans. Okay, ERR TR. So this is one memory location. This is another memory location. So what is happening? If you are changing data, Here, if you are changing the value of data in TR1, it will be only limited to data TR1 only. It is not against TR2. That means TR2 won't be affected if you are changing data here. Again the same thing. If you are changing ID here, it is only limited to TR2. There won't be any effect on ID. But that is not the case with error transaction. Why? Because error transaction, if you are assigning the values, if you are assigning by using a shallow copy, what happens? Any values that were created within the transaction, because if you see here, data and ID are the handles that you have created in the transaction class, but error transaction is the class even though you have created in transaction, but its origin is in the error transaction class. Okay, which inside consists of again two values like error data and error. So which is why, since it is having origin somewhere, so that origin can't be copied into this particular. By using a shallow copy, you can't copy this particular. Even though you can copy the handle, you can't copy the origin of that particular values that are present in that error TRR. Got my point? So now what happens? This data and ID is having different memory locations, but ERR TR is sharing the same memory location for both transaction 1 and transaction 2, which is why if you make any changes in error TRR values, it will be affected in TR2. Again, if you change with TR2 handle also, it will be affected in TR1. Let me show you an example for it. So here, until here you got it clear, right? TR2 equal to new TR1. Now what happens? Dollar display after shallow copy. What are the, again I am calling TR with TR2 display. Okay, before copying I have called with TR1 display. After copy I am calling it with TR2 display. And then after displaying everything, after display is done, like I have called with TR1 display and TR2 display, like everything is displayed clearly. Now what I am doing with TR1 handle, I am changing the values. Why I am telling that the changing the values? Because before I have already assigned the values. What are the values that I have assigned? Data is 100, ID is 1, error data is all F's and error is 1. So these are the values that I initially assigned. But after copying, after shallow copying, I am changing the values in TR1 data as 202. Okay, and TR1 error TRR. So if you see this, this is the hierarchical path for error TRR. So I am changing it since it is having all F's, right? And here the value is 1. So I am changing it to 1, 2, 3, 4 and 0. Now I am giving it with TR1 dot display and then TR2 dot display. Okay, so let us see how the output will be happening. So at first, when we are calling with TR1 display, before like this display function is before the copying technique happening, like here. Okay, before copying technique happened, this is the display for that. When I am calling TR1 dot display, so what is the values? 100, 1, all F's 1. Okay, after shallow copying is 1. What happens? Since I copied everything from TR1 to TR2, so basically all the values are copied as it is, like data is 100, ID1, FF and FF. So now after shallow copying is done, now the changes after, if you see here, after this is the place where I started changing. After this signal I started changing here. So with TR1 one handle only I have changed everything. If you see here, with TR1 handle only I have changed everything. So now let us see the output of TR1. So the TR1 output is 200 to 12340. Right, now TR2 handle. So with TR, now this is the TR1, with TR1 handle I have made every change. So what is the output in TR2? That is before only. Like if you see, data is 100, ID is 1. But as I told you, if you see here, since both of them share the same memory location, so the error transaction of TR2 is also changed from all F's to 1, 2, 3, 4 and 0. Clear? So this is about the shallow copy. This is how the shallow copy exists. So in order to avoid this, like in order to make this particular internal objective is also to not to change, even if we are making any changes, the the deep copy has occurred. Okay, so what is the thing that we are doing extra in deep copy in order to avoid this particular a mismatch in this internal objects of that particular transaction handles. Okay, so we'll be seeing it in the next class. If you like this video, please do give it a like and also share this to all the VLSI aspirants who also want to enter into design and verification domain. Also, I have made a video on what are the job roles related to design and verification domain in VLSA. I link that also in the description box. You can go there and check it out if you are a fresher, and you can understand what are the job roles that you can get when you enter into the real-time VLSA domain. Right. So that is all for today. Thank you.